operator and operand to do that. We are only currently allowing multiple variables to be defined. If you wanted to do bonus, here's a bonus challenge for you. Change the grammar so that instead of just allowing an operator and an operand, that you actually allow multiple operands. So operator, operand, X, Y, and Z. So bonus. And the last part of the assignment is, so that's parse. It's basically what you have to do for this assignment, is just do that, what we just did, and then extend it a little bit to handle this variation, the list and the multiple items, variable number of arguments. Starting a new one?
Yes.
Okay. And then the last part is to be able to do, what did I call it? Pardon? So you have to parse, occurs free and unparsed. Say unparsed. So unparse is going to take one of these things, just a list of symbols with the lambda exp, the var exp. Those are just symbols, and you're going to break that up so that you'll write unparse expression. And in fact, an easy way to check it would be to do this. You parse the expression, you unparse the expression, and you should get back exactly what you started with. So questions? So the book has a hint about how you add multiple things using this thing called list of. I think it's a question mark. Yeah. This is on page 48. So you'll want to use list of as your test so that you can go through the items and see if they you have a list of appropriate things. So you can probably do this assignment by just like 10 character changes to the program that we just wrote. Go and change a couple. You can even do the bonus, I think, in those 10 characters. Just have to know where those 10 characters go. So any general questions? You see where we're going? So somebody repeat what it is that we're doing and why? Sum it. Taking a concrete syntax, moving it into an abstract syntax. Why?
Because it gets really complicated.
Yes. So once we have the abstract syntax, writing the interpreter will be a whole lot easier. If we were trying to interpret just the raw string, we'd go crazy. But by taking this into this nice abstract representation, we can go through this very easily. And so you saw our parser? Our parser is 12 lines of code. Now, granted, it's a pretty simple language, but it's the core of lambda calculus. You've got application, you've got variable creation, and you have variables reference. So our entire parser for that entire language is 12 lines of code. Unparser, going to be another 12 lines of code. Interpreter, probably about 12 lines of code. So we're going to be able to actually do things in just that amount of code. Francine, do you have a question? No? Asha? No? Sarah? No? 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 Straightforward? Easy? So, of course, our grand plan is by the end of the semester, you'll be able to take a string in whatever format you want, curly braces, indentation, whatever you want to make it meaningful. You'll be able to turn that into an abstract representation, maybe this exact abstract representation, and then just interpret that, and voila. You've got amazing, powerful language that you define really subtle issues like scoping, exactly how your language works, which we'll get into next. What are the issues that actually go involved about, making your system so you can add two numbers together, or add a variable to another variable? That is next. Question? All right. Well, we're going to end a minute early in celebration of Grace Hopper. Have a good weekend. I have office hours on Friday and Monday. Open lab on between 2 and 3, and on Monday, and by appointment, and via email 24 hours a day.